Hello guys, in this video I'm going to talk about the motivation for histogram specification. So basically in the last video I talked about the motivation for histogram equalization. So there we saw that when we equalize a particular, we saw what is the algorithm for histogram equalization, why does it work, how did that algorithm come in the first place. So we saw it gives a pretty good image enhancement. It flattens the histogram and does all sort of good things. But then we also saw it does not work on all the images. So in case if you have not seen my histogram equalization, motivation for histogram equalization video, I please encourage you to watch that video first. So basically this is a continuation to that video. So we saw that this histogram equalization technique does not work for every image. Here you can see this image is having patches over here of white. Here these pixels are sort of abruptly changing. So it is not a very nice image. Though its histogram is quite nice, it is using all the grayscale values, but then the image is not that nice. So we were talking about then why, then what next. So what next can we do to enhance the image. So then there comes a concept of required histogram. So this is the best possible enhancement that we can do with the given histogram. So if suppose this is not nice, so if this is not acceptable, then what we ask is, okay, come on, you give me a histogram and I will make the image according to it. So here in histogram specification there is a required histogram. So there are two things that we have to give to the algorithm. So there is this image which needs to be modified. So this image has to be modified, and we have another image. So we have this image histogram over here, and we want to modify this given image such that its histogram transforms and looks something like this. That is our task in histogram specification. So what histogram specification basically tells us is, okay, you give me a histogram and I will make the given image histogram as the required histogram. That is what we do. So here I've chose this image because you can see that it is basically using all the colors that are available. It is from 0 to 255, so it is using all the colors. And if you see this image, it is having a lot of bright pixels over here, so it has white pixels more, and the same trend is also observed over here in this image. So this is the main reason for choosing this image. So basically for histogram specification it is very important that you choose a good image which is in accordance to your image. Any image will not work, so you will have to choose an image which is in accordance with your given image, and try the algorithm. So let us see what is the algorithm. So let me consider R as the gray levels of the given image. Let me consider Z as a variable for the gray levels of the image of the required histogram. So what histogram specification basically tells us is, we first equalize both the images. So when we equalize both the images, let me denote S as the gray levels of the equalized image of the equalized given image, and K as the gray levels of the equalized image of the required histogram basically. So S will be some T of R, where the T is a transformation for the input given image, and we have seen in my previous video that this transformation function is nothing but the CDF of this image. That is how we do histogram equalization. Similarly, G is the CDF. This function G of Z is nothing but the CDF of this image. Uh, that is we have seen in histogram equalization. So when we compare both these equalized histogram, we see more or less it is similar. So the histograms are more or less very similar to each other. So what we do is we can equate both of them. So I can say S is equal to K. I know this is wrong. I cannot actually do that because I can see that there are some values over here which are high, but then that is not the case over here, and there are some values over here which are different, which is true. But then suppose if I equate both of them, so what this gives is basically I get G of Z. So G of Z is equal to T of R. That is what I get next step. So what is my motive? My motive is to transform R and make it like Z. That is my motive. I have to transform this R in a way that it becomes Z. So by this, if there is some inverse transformation that exists, which does exist, because this transformation is nothing but the CDF. So I can inversely map the CDF. So we will see this very nicely when I go to MATLAB. So I'm going to make a video where I'm going to show the algorithm in MATLAB. So this inverse operation will be very nicely seen over there. How do we do this? And we will get Z. So now the point is that since both of these are not actually equal, we will not get equal values basically. So what we do exactly is we assume G of Z greater than or equal to T of R. So you can also see in my next video when I have given an example, so how there I have used G of Z greater than T of R. So the basic reason why I am doing that is because of this. So I cannot equate it blindly because things are different over here. So this was just to basically get the notion of why I'm doing this, so that I can get Z. So if I have R, I transform it by the CDF, and then the inverse transformation of this image is CDF, I can convert it to Z. So that is what we are doing in histogram specification. So when I run this particular code, when I use histogram specification, you can see that this is what I get. So you can see that the histogram of the given image is now become like this. You can see how beautifully it has tried to copy the histogram of the required histogram basically. So you can see that it is very similar to the required histogram when I apply these steps basically. So here you can see, also you can see that the image is also looking pretty nice. Let us zoom in and first see. So right, so this is basically the histogram, the actual histogram of the given image, and this is the histogram after histogram specification what we have got. So when I zoom both of the images, so here I can see all those patches are gone. So the patches that I used to get in histogram equalization are gone. So this looks a very pretty image, a very beautiful image. Here you can see this is a dark image and this has become bright, and it has no patches over here, and it is giving a very good contrast, very good image. So that is the basics of histogram specification, and this is the main. So basically to remove some of the problems of histogram equalization, we came to histogram specification. So I hope you understood this well. About the algorithm, I'm going to upload a MATLAB video. So in the MATLAB video, these things would be much more clear. Also, I have taken a sum, so you can also see how we are utilizing this fact in the sum. How can we get the inverse basically in the sum? So that is also that we can see. And thank you so much for watching. Stay tuned. I'm going to upload the MATLAB videos very fast. Thank you so much.